All right, there is a special rule for decomposition, recognizing that decomposition is a compound by itself when you have compound yields. All right, there are 4 exceptions to the rule. The first exception is when you have a chlorate. Now, normal decomposition would be something like NaCl yields, compound yields. All you do in that case is break it apart. So you'd end up with Na plus Cl2. And of course, balance it there. Okay? Now, when you have these special exceptions, you have to memorize what's going to be produced. They are fairly intuitive in that if I have a H in the reactant, what do I have in the product every time? Water. So if you kind of forget and it has an H in it, water. And then you can try to figure out and notice that every one of them is compound plus compound except for the chlorate. Compound plus compound as your product. So again, that might help. And 3 out of the 4 end up with some kind of oxide. The only one that's doesn't give you an oxide is chlorate. It gives you chloride. So let's start off. We'll use aluminum, AlClO3 yields. That's a metallic chlorate. Now I have a blank here, and what goes in the blank is the metal. What goes in the blank is the metal for all of these except for the acid, and then it's whatever the polyatomic ion first element is goes in the blank. Most of the time it's a non-metal. That's why I have NM. An exception would be chromate. Chromic acid would be an exception because chromium is in the transition metals and not in the non-metals. So there are exceptions to this being a non-metal. Don't let it confuse you. It's just the first element of the acid. First middle element of the acid. All right, so I have, in this case, I'm going to have AlCl plus 3 minus 1, -3, plus O2. Then, of course, you have to balance side to side. Now, I found on a website that I was looking at another way to do the T thingy, and it might even be better, where they put AlClO, like that, in the middle. And then they said, over here I have 1, and I have 1, over here I have 3, and I have 3, and over here I have 3, and I have 2, odd even thing going on. Double the first thing you did, 2, 2, 6, 6, and now I have, whoops, I forgot to put my 30 right there. Oh, let me forget. Okay, so now I have my, I had a while ago I had 9 and I had 2. So now I've got 18 and I have 2, so I need a 9 right here. All right, balancing side to side on these is not hard. The hard part is recognizing when I'm going to do the 5 exceptions that I'm teaching you. You have 5 exceptions. Very active metals with water, CH compound with oxygen, and now you have these 4 right here. There's 6. Addition is not too good. So I have 6 exceptions you have to learn. All right. Now OHs, again, I'll go with the AlOH, and it's going to produce Al2O3 plus H2O. All right, I have 2 Als. I have 6 H's. I've saved those for last. I have 6 H's, so I'm going to put a 3 here, and I have 6 O's over here, and 3 plus 3, 6 O's over there. Now in your homework for tomorrow, I have given you one with plus 3 metal, a +2 metal, and a +1 metal on each one of the decomposition reactions. You need this thing there. All right, so on your homework you'll have one of each one of them, so you see how to balance them, but you have to recognize which one of the decompositions they are. All right, so on the next one is the carbonate. Now on this one, I can virtually see CO3 producing that CO2. Okay? To help me remember that CO3s produce the CO2s. Alright? This is not a C, it's a parenthesis. So I have 2 ALs and 2 ALs. I have 3 Cs, so I'm going to put a 3 right there. I have 9 O's. So over here I have 3 plus 6 equals 9. Okay? It's the recognition process that you have to do. All right? Now, my thing is recognize the type of reaction. When I say it's a single replacement, I need to think of those 2 exceptions. Reactive metals and the CHO reaction. When I see it's a decomposition, I have to think hydroxide, carbonate, chlorate, and acid. If it's one of those 4 things, then I have to think what is produced from those 4 things in decomposition. All right, now the last one is the hard one, this one. You have to do algebra. Do algebra. All right, now, some of you did not learn how to do this algebra last time. You're going to have to learn to do it this time. So let's start off with H2SO4 yield. So what type of reaction is it? Decomposition. Is it one of the 4 exceptions? Yes. So I have to think my products are going to be SO plus H2O. Remember, when there's an H there, I'm going to produce water in this decomposition route. Now, I have to balance SO. What's the charge of O? -2. What's the charge of S?
-2.
Can it be -2 and equal 0? No. Remember that these nonmetals can be forced to have a positive charge. If they're combined with an element that is stronger than they are, stronger electronegativity, then they can be forced to take a positive charge. It's like I told Allie second period. She wants to play goalie. Well, if I'm stronger and better at it than she is, she ain't going to get to play goalie. I'm going to make her have to play something else. She wants to play goalie, but I'm going to take her place. So that's what happens. Oxygen is very strong in its electronegativity, so it forces these other nonmetals to take a positive charge. So sulfur can be a +2, a +4, or a +6. I got to figure out which one it is, because whatever it is over here, it's going to be the same over there. So what we do is pull out one polyatomic ion. So here's my polyatomic ion. Pull it out. Set it equal to, any ideas? -2. I don't set it equal to 0. I set it equal to its charge from the from your pink sheet. Pick your charge from the sheet. Now, I always know what oxygen is. It's a -2. So S plus 4 times -2 equals -2. Now, of course, you don't have to go through all these steps. And on the next time, I won't go through all these steps. But I want to make sure everybody sees the algebra. Okay? So, S minus 8 equals -2. Somebody from first period said, I said, what do you do next? Do I add 8 to both sides? Yeah. You know, y'all passed that algebra test. You should know that. So yes, I'm going to add 8 to both sides. And S is equal to plus 6. So if it's a plus 6 here, it's a plus 6 here. So I balance that compound. SO3. Now what's the name of that compound? Sulfite. No, it's not sulfite. Sulfur trioxide. Remember, you don't look on the pink sheet to name a compound. Alright, so balancing, I have 2 H's, 2 H's. I have 1 S, 1 S. I have 4 O's over here, and I have 3 plus 1 equals 4 over there. So it's balanced. They don't all balance quite that easy, but that one does. Okay? Those with the plus 2 charge balance very easily if you know what the charge of the nonmetal is, or the middle element. Alright, so let's do another one. Let's do H3PO4 yields. We know that it's going to produce the PO plus H2O. And we need to know what the charge of the P is. So I'm going to do a shortened version of what I did a minute ago. Pull out the PO4, set it equal to its charge. Minus 2, I'm going to visually say, I can say minus 2 times 4. So P minus 8 equals minus 3. P equals plus 5. Okay? Left out all those other little steps. But if you need them, you write them. Okay? If you don't need to write any steps, don't write any steps. I know Matt doesn't need them. He just goes through. Zach, you know what that charge is by looking up here and mentally thinking about it. So doing the mental math. So if it's a plus 5 here, it's a plus 5 here, and that's still a minus 2. So we balance. Alright. So I need to have, I have 3 and 2, odd even. I'm going to put a 2 here and a 3 here. And that gives me 2 P's and 2 P's. It gives me 8 O's, and 5 plus 3 equals 8. If you find the charge of the P, the balancing is easy. The balancing for these is easy. The hard part is saying, that's a decomposition. Is it one of the 4 exceptions? You can't just go through there and say, oh, yeah, and just write down. You got to put the brain into it. All right. Any questions?